Large language models.
Yeah.
I mean, whether you're using them for boiling down dense research, fixing tricky code, or just drafting emails, they're incredibly smart, aren't they?
Oh, absolutely. They're generalists, really brilliant ones, trained on this vast sea of information.
But that's the thing, right? Generalists. What happens when you don't need a generalist?
Hmm.
What if you need an expert, someone or something that really gets your specific world, your company's data, your technical field, your unique way of writing?
Yeah, you need more than just broad knowledge then. You need depth.
Exactly. You need a specialist who speaks your language, you know?
And that's precisely where fine-tuning comes in. It's the process of taking that general brilliance and making it specific.
Okay, let's break that down for everyone listening.
Yeah.
So fine-tuning is basically taking this super smart, pre-trained AI and tailoring it, sharpening it for a particular job or knowledge area.
That's a good way to put it. And it works for text models, LLMs, but also for multimodal ones, the MLLMs that deal with images and audio too.
Right. I like the analogy you used before we started. It's like hiring this genius apprentice, right? They've aced every textbook, understand all the theory.
But they have zero clue about how your specific workshop runs. Your methods, your standards, your, let's say, secret sauce.
Oh. And fine-tuning is that apprenticeship. It's the hands-on training where you teach them your craft your way.
Exactly. It's focused instruction.
So our goal here today is to really unpack that. We want to give you, the listener, a clear view of not just what fine-tuning is, but really why it's often necessary.
And crucially, how it's different, practically speaking, from the massive undertaking of training a model from the ground up.
Plus, we'll look at the 3 main ways you actually teach a model to specialize. Sound good?
Let's dive in.
Okay, so first up, why even bother? Why can't these already brilliant general models just handle specialized stuff?
Well, they often lack the necessary depth. They know little about everything, but when you get into really niche areas, like specific technical writing or analyzing complex proprietary data.
The answers get vague. Or maybe just wrong.
Exactly. Generic, sometimes unhelpful, or even misleading because they don't have that deep specialized context.
Right, so fine-tuning fills that gap.
It does, and it targets some really key objectives that just prompting, giving instructions in the request often can't consistently hit. There are 4 main ones we see.
Okay.
First, you need accuracy in that niche. Think medical diagnosis, legal contract analysis you can't afford mostly, right?
Absolutely critical. What's second?
Consistency. You need the model to perform at that high level every single time for every user, for every similar task. No surprises.
Makes sense. Predictable quality.
Third is efficiency. A well-tuned model should give you fantastic, detailed results, even from quite short, simple prompts. You shouldn't need to write an essay just to ask a question.
Ah, so it saves time and effort on the user's end.
Definitely. And the fourth, which is maybe a bit more subtle but just as important, is voice control. Meaning the output needs to sound like it came from your organization or your specific expert role. It has to match your brand's tone, style, the level of detail you expect.
Got it. So it's about capturing that unique fingerprint.
Precisely. Now, you can try to get there with really elaborate prompts.
Right, like giving it a huge chunk of instructions every single time.
Yeah, but that's inefficient, like you said. Fine-tuning is different because it sort of bakes that knowledge, that style, that voice right into the model's core workings.
So the model internalizes it rather than just following instructions for that one query.
Exactly. It becomes inherent.
That's a really important distinction. But okay, this sounds powerful, but does it mean it's incredibly expensive and time-consuming, like building these models in the first place? That puts it out of reach for most people, right?
Well, this is the really key point, and maybe the biggest aha moment for a lot of folks. Fine-tuning is not the same as training from scratch. Not even close.
Okay, explain that difference.
Training from scratch is like teaching a child language and how the world works from zero. It's foundational. You need unimaginable amounts of data. We're talking petabytes.
Petabytes, wow.
And it costs millions, literally millions of dollars in computing power and takes weeks, sometimes months, of continuous processing.
Okay, so definitely not something a small business or even a medium-sized one could realistically do.
Generally, no. It's reserved for the big players, the foundational model builders. But fine-tuning, that's building on the foundation that already exists.
Right, the apprentice already knows how to read and write and reason.
Exactly. You're just teaching them your specific trade. So the resource difference is just massive. For fine-tuning, you might need thousands, maybe up to 1 million examples. Still a lot, but vastly less than petabytes.
Okay, thousands to 1 million versus petabytes. Big difference. What about cost and time?
Cost drops from millions to maybe hundreds or low thousands of dollars, depending on the scale and method.
Hundreds or thousands versus millions, okay?
The time shrinks from months to maybe hours or days.
Hours or days. That makes it actually feasible for a lot more people, for specific projects, for specialized tools within a company.
Totally. It democratizes specialization.
Yeah.
Training teaches the language. Fine-tuning teaches the application of that language within your specific domain. And importantly, it teaches judgment, what a good application looks like for you.
Especially with those preference methods you mentioned.
Yes, exactly. Those are all about refining judgment.
Okay, we've got the why, accuracy, consistency, efficiency, voice, and the cost. Way, way cheaper than training from scratch. Now let's get into the how. You mentioned 3 main ways to teach this specialization.
That's right. They sort of build on each other, depending on your goal. The first is continued pre-training.
Continued pre-training. What's that about?
This is purely about absorbing domain-specific knowledge. You basically just feed the model tons of raw text from your specific field. Think research papers, internal manuals, technical documentation.
So no fancy instructions, just reading material.
Pretty much. The model learns by doing what it originally did, predicting the next word in sequence, but now only within your specialized texts. It soaks up the vocabulary, the phrasing, the common concepts of that niche. No human examples of right answers needed yet.
So using our punk Victorian tailor analogy from before, you'd feed it like old tailoring manuals, books on corsetry construction, but also maybe texts on punk aesthetics, metalworking techniques.
Exactly. It learns that terms like boning channels and grommets belong together and understands the context around distressed finishing, maybe differently than a general model would. It just learns the language of that specific world.
Got it. So that builds the vocabulary foundation. What's method 2?
Method 2 is usually the real core of building a useful tool, supervised fine-tuning, or SFT.
SFT, but
Here, you're not just giving it text to read, you're actively teaching it how to respond. You do this using carefully crafted input-output pairs.
examples, basically. Like if the user asks this, the perfect answer looks like this.
Precisely. You show it exactly what an expert-level response looks like for a given prompt. This is where you teach the skill.
So for our tailor bot, the input might be draft a pattern for a fitted waistcoat with 6 panels and backlacing.
Right. And the output part of that training pair wouldn't just be any waistcoat pattern. It would be a detailed, structured description following the house style. Utilize 6-panel block derived from 1880s men's pattern. Specify princess seaming for fit. Rear closure. Functional corset lacing via 12 pairs of steel grommets set at 1.5-inch intervals.
So it learns the link between the user's request and the specific technical styled output you expect.
Exactly. It learns the task execution.
Okay, makes sense. And the third method, you mentioned preference.
Right. Method 3 is preference-based tuning. This is less about teaching factual correctness, SFT handles that, and more about teaching, well, preference. Judgment, style, tone, alignment with perhaps more subtle human values.
How's that work?
Instead of one perfect answer, you give the model 2 or more possible responses to a prompt, and you tell it which one is better. Response A is okay, but response B is preferred.
So comparisons.
Yes. Historically, this was often done with something called reinforcement learning from human feedback, RLHF, which got quite complex.
Right. I've heard of RLHF.
But nowadays, simpler and often more effective techniques like DPO, direct preference optimization, are becoming standard.
DPO. How's that different? Is it easier for people to implement?
Generally, yes. DPO is more direct. It skips a step in RLHF where you had to train a whole separate AI model just to predict which response humans would prefer, a reward model. DPO builds that preference directly into the main language model by showing it pairs of chosen and rejected responses.
Okay, so it streamlines the process of teaching the model this is better than that.
Exactly. It helps you fine-tune those nuances. Is the tone right? Is the level of detail appropriate? Is it helpful and safe? For our Taylor example, maybe response A gave basic instructions, but response B included specific notes on balancing the structure with the punk hardware aesthetic. You'd mark B as preferred.
And over thousands of these comparisons, the model starts to develop that specific taste or judgment you want it to have.
That's the idea. It learns the subtle qualities that make an output truly good for your needs, beyond just being factually correct.
Okay, that makes a lot of sense. Continued pre-training for vocabulary, SFT for task execution, and DPO for refinement and judgment.
Those are the core methods.
Now let's kick under the hood a bit.
Yeah.
When we say the model learns or we adjust it, What's actually changing? You mentioned parameters.
Right. So these large models have billions, sometimes trillions, of internal knobs called parameters. Think of them as weights that determine how information flows through the model's network and ultimately influences what word comes next.
Billions of tiny knobs controlling the output.
In essence, yes. Fine-tuning is the process of carefully readjusting millions of these knobs. Not randomly, but in a very targeted way based on the examples you provide.
So when we feed it those SFT pairs, the prompt and the expert answer.
The model tries to generate the answer based on the prompt. Then the system compares the model's attempt to the perfect answer you provided.
Okay.
The difference between the model's attempt and the target answer is calculated as a value called loss. It's basically a score saying, how far off were you?
Right, the error signal.
Exactly. And the goal of training is always to minimize that loss, to reduce the error.
And how does it actually reduce the error? How does it know which of those billions of knobs to turn?
That's where a mathematical process called gradient descent comes in. It's an algorithm that calculates for each parameter which way to nudge it up or down just a tiny bit in order to make the loss slightly smaller on the next attempt.
Okay, so it figures out the downhill slope towards a better answer.
That's a great analogy. It finds the direction of steepest descent for the loss and takes a small step that way, adjusting millions of parameters simultaneously. It's not about massive changes, it's about tiny, coordinated nudges.
Like you said with tailoring, you don't rip the whole seam out at once. You pin, check, adjust by a tiny amount, check again.
Precisely that. This cycle, make a prediction, forward pass, calculate the loss, figure out adjustments, backward pass. Update the parameters repeats thousands or millions of times with your training data.
Until the model gets really good at predicting the expert outputs for the kinds of inputs you've shown it.
Correct. And crucially, it's not just memorizing the specific examples you fed it. If the data is good and the process works well, it learns the underlying logic, the patterns, the style connecting the inputs and outputs.
Ah, so it internalizes the reasoning. That's why it can generalize later.
Exactly, that's the magic. Once tuned, you could ask our tailor bot, design a three-piece suit, Victorian military style, but with punk hardware, and it should be able to apply the learned principles of structure, style, and hardware integration to that new request, even though it never saw that exact suit combination in training.
It's learned the craft, not just the blueprints.
That's the goal. But there's a crucial next step. How do you make sure it actually learned correctly and didn't just, find some weird shortcut?
Right. How do you test it? Validation, I assume.
Absolutely critical. You need a separate set of examples, a held-out validation set that the model never saw during the tuning process. You use this set purely for testing.
Why is keeping it separate so important?
It prevents you from fooling yourself. It helps catch two main problems. First, overfitting.
Overfitting.
Yeah.
That's like memorizing the training data too well.
Exactly. The model gets perfect scores on the data it trained on, but because it memorized instead of learning the underlying patterns, it performs terribly on any new, slightly different data. The validation set immediately reveals this.
Okay, so it checks for true learning versus rote memorization. What's the second problem?
It's particularly relevant for preference tuning, like with DPO. It's called gaming the reward or gaming the metric. The model might figure out a way to consistently get marked as preferred by, say, always being super verbose or always using certain keywords, even if the output isn't actually helpful or high quality.
It finds a loophole to get a good score without doing the job right.
Precisely. Testing on unseen validation data, often with human review as well, helps catch this. You need to ensure it's genuinely better, not just better at tricking the comparison metric.
This sounds like the data you use for tuning is just paramount.
It is the most important factor, and here's the key takeaway for anyone looking to do this. Prioritize data quality over sheer volume.
Quality over quantity. Why is that so critical? It feels like more data should always be better.
Because the model learns exactly what you show it. A small set of, say, 500 perfect, consistent, well-crafted examples that truly represent your desired output will teach the model far better and faster than 50,000 messy, inconsistent, or low-quality examples.
Garbage in, garbage out, basically.
Absolutely. If your training data has errors, inconsistencies, or reflects a standard lower than what you actually want, the model will learn those flows. The rule of thumb should be, if you wouldn't want your human team learning from this example, your AI shouldn't learn from it either.
That's a really clear standard. Clean, high-quality, representative examples are key.
It's often the hardest part of the whole process, curating that excellent data set.
And I imagine this isn't just a one-time thing. You fine-tune it, deploy it, and you're done.
Definitely not. The world changes, your standards might evolve, new techniques emerge in your field. Fine-tuning needs to be a continuous process.
So ongoing maintenance.
Yes. Ideally, you need a system in place, often called a human-in-the-loop system, to collect feedback on the deployed model's performance. Are users flagging bad responses? Are there new types of requests it's struggling with?
And you use that feedback too.
To gather new training data, identify weaknesses, and periodically rerun the fine-tuning process to update the model, keep it sharp, and ensure it evolves along with your needs and your domain.
Right, so it stays specialized and relevant.
Exactly. It's iterative.
Okay, so pulling this all together. Fine-tuning isn't about building an AI brain from scratch. It's about taking an existing, incredibly smart, generalist AI, that brilliant apprentice, and putting it through a structured training program. Using your own high-quality examples and maybe preference comparisons, you teach it the specific knowledge, skills, style, and judgment needed to become a true expert in your specific domain.
That's it perfectly. You're transforming general intelligence into specialized craft.
And the payoff is significant, it sounds like.
It really is. You know, a base model might handle 80% of what you need pretty well, which is amazing. But if you need that reliable, consistent, high-quality performance for your specific critical tasks,
The last 20% is crucial.
it's often the most crucial part. Thoughtful fine-tuning is what bridges that gap. It pushes you from, say, 80% accuracy or consistency up towards 95%, 99% for your specific needs.
Which can make all the difference between a useful tool and an indispensable one.
Absolutely. If you're using a general model for a job that demands real specialization, you're likely leaving significant performance, efficiency, and consistency gains on the table.
So here's a final thought maybe for you listening to mull over.
Yeah, I think the really profound thing here is that when you fine-tune a model carefully, using your best data, reflecting your actual standards and preferences, you're doing more than just customizing software.
How so?
You are, in a very real sense, teaching an AI to think in your professional language, to reason according to your domain's logic, to create outputs that embody your expertise and even your values.
So it's like encoding your specialized way of thinking into the AI.
Exactly. You're transferring not just knowledge, but judgment and craft. And that transition from the general intelligence of the base model to this deeply internalized, specialized expertise, that's the transformation that's truly starting to reshape how work gets done in countless fields. It's about making AI speak your language.